Here is the pinout for the Sculpfun board, the XY DLC V1.1. There may be some other boards similar and might have the same setup. Here's the resume switch that connects to A2, and the A1 goes to the Arduino pause pin. And you need to have a ground common between the Arduino and the Sculpfun. Up on the left there's your fire detectors. They're all powered with 5 volts, and the outputs go to the inputs, the digital inputs of the Arduino. You got your lid switch, your buzzer, and your LED. Make sure you use appropriate resistor for your LED. Okay, this is an overview of the Arduino Sketch. It's basically for 4 IR, fire / flame sensors plus a lid switch. This one's set up for Arduino Nano, but will probably work for pretty much any Nano, Pro, Mini, yeah, anyway, Mega or regular Arduino Uno. The inputs are, each input is for flame sensor, so pins 2, 3, 4, 5, and then pin 6 is the lid switch. Each one of these is active low, so when you send it a low, that means it's detected fire. And then if the lid switch is open, it sends a low to say it's detected the lid switch is open. The outputs are LED pin 7, buzzer pin 8, pause pin 9, and onboard LED is pin 13. If you don't want LED and buzzer, you just don't have to hook that up. You do need the pause output to go to the laser board. This set of variables here are just to hold the state of the switch when they're red. And then there's a current state that needs to be changed when a state changes in order for you not to get repeated detection of a fire over and over and over. You only need to detect it once until it's reset. There's a debounce of 500 milliseconds, and that's basically whenever you press a switch or some sensor sends out a signal, it could go high-low really quick, and you want to get rid of that. So this is set to 500 milliseconds or half a second. You can change that if you want faster detection, but honestly, it's fine that way. The setup is pretty simple. We just turn on serial beginning to monitor the outputs if you need to debug, but you can get rid of any serial writes here if you want. The configuration for the I/O pins is all of them are input pull-ups, and then the buzzer, LED, pause, and outboard LED output is all set to output. And then we set the initial state of the pins here to low, low, and then we set the pause to high as the initial state because the laser requires a low for active to say please pause when I see a low on the A1 pin. The OLD onboard OLD pin is also set to low to keep that LED off. The void loop is pretty simple. It first uses the the debounce delay time to check and see if time has passed long enough to set the variable flame A with the digital write or digital read from flame pin A, and then resets the debounce time. And we do that for each sensor and the lid switch. So now that information is stored in the variables, we check to see if any of them went low. If any of the flame detectors went low or the lid switch went low, then we go to the next check, which is if current state is 0. That means that the last state was not paused, so therefore we can check the next thing is were any of the lows from flame detection. If they were, we are going to set the pause fire and execute that that small script. Else, if none of them were the low, then we need to check and see if it was the lid switch. If it was the lid switch, we set the lid switch outputs here, and then we change the current state to 1. If the flame, if none of this occurred, and if the flame, all the flames are high and the lid switch is high, then this says you're in normal operation and you have no warnings. And then we set not pause situation, and we set the current state to 0, so it's waiting for the next fire or lid opening state. So each one of these set pause fire is just saying that digital write buzzer is going high, the LED pin is going high, the pause is going out low to pause the printer or the laser, sorry, and then the onboard LED pin will go high to light that up. And then I just put a simple debug line here that says fire in the engraver, extinguish fire, close lid, and press resume button when ready. The next scenario is set pause on lid opening. We don't set the buzzer on this one because just because you open the lid, you don't want to hear the buzzer, I'm sure. LED pin set high, pause set low, and the onboard LED pin is set high, and then statement says lid open, press resume button after lid is closed. And the last one is set not paused. Basically, everything's good, don't pause the laser. So you set the buzzer to low, LED pin to low, set pause to high, telling the laser it's okay, don't pause, and the onboard LED pin to low. Then statement says no flame, lid closed, press resume button to resume. So that's it for the sketch. I'll have the sketch loaded on my Google Drive so you can download that, and please let me know in the comments below if you have any questions or any other requests, as this was a specific request. My initial method of doing this was through Blink app, so I can get a notification as well, but that is a little bit more complicated, and I can't really explain how all the Blink script works per se. So if you want to dig into that, let me know. I can show you what I got and you can go from there. Thank you.